In this recording, I'm going to go over practice exercise 1 from chapter 19. We're asked to identify the oxidizing agent and reducing agents in this oxidation reduction reaction. So a couple things to keep in mind. When we say oxidation reduction reaction, this is just another way of saying a redox reaction. Remember, the oxidizing agent contains the element that is reduced. The reducing agent contains the element that is oxidized. We're going to use our rules from our study guide about assigning oxidation states as we go. Aluminum, any element by itself, has an oxidation state of 0. In a compound, nonmetals, hydrogen has priority. Each hydrogen is +1, which means oxygen must be -2 because all of the oxidation states must add to 0 in a neutral compound. Notice I'm ignoring the coefficient of 2. You only assign the oxidation states for one molecule. Once you assign the H and the O oxidation states for one water molecule, you know any other water molecule will have the same oxidation states for their individual elements. MnO4-, -1 charge. I don't know the charge of manganese, it can change, but in an ionic compound, oxygen has an oxidation state of -2. And I have 4 of them. So I like to write it 4 times to really emphasize the fact that each oxygen itself has an oxidation state of -2. You just happen to have 4 of them. I know that all oxidation states must add to -1. Therefore, manganese must be +7. Because -2 times 4 is -8. +7 equals -1. Now let's look at aluminum hydroxide. I like to think of this just as hydroxide, OH- and Al3+, ionic compound. It's actually a coordination complex that we'll talk about in chapter 25, but right now we can look at just the 2 ions, aluminum and hydroxide. Well, aluminum in the 3+ ion has an oxidation state the same as its charge, which is +3. For hydroxide, O and H has a higher priority from our list, +1. Oxygen, well, I know they must add up to -1 because that's the charge on hydroxide. So oxygen must be -2, which is indeed the oxidation state it prefers. MnO2, ionic compound. In a compound that's ionic, oxygen has an oxidation state of -2 because that's the same as its charge. Manganese in this case, well, this is a neutral molecule, there's no charge, so it's 0, -4 for the oxygens. Manganese must be +4. So that's the first thing, assigning oxidation states to every single element. And now we want to identify the oxidation states that change from reactant to product. My H's are +1 in the reactant, +1 in the product, so hydrogen was not oxidized or reduced. Same with oxygen. Right, -2 everywhere on the reactants, -2 everywhere on the products. But now let's look at aluminum. I see that aluminum has an oxidation state of 0 on the reactants, +3 on the products. So what happened? Became more positive. So did it gain or lose electrons? Remember, electrons are gained and lost as negative charges. So if we have an oxidation state of 0, 2 + 3, that means we lost electrons. And let's look at the other element that had to change an oxidation state, and this is indeed manganese. Went from +7 to +4. It became less positive by gaining electrons, which is reduction. So now let's figure out oxidizing agents and reducing agents. So the oxidizing agent contains the element that is reduced. Manganese is reduced. Therefore, the oxidizing agent is MnO2. NO4 minus. Our reducing agent contains the element that is oxidized. That is therefore our solid aluminum. Hopefully this was helpful.